So today seems like we're going to have a lot of fun together. First, because we will be using a lot of functions, which is obviously fun. And second of all, just my personal note, it's a lot of fun for me because I've learned today that I'm going to give this talk like 10 a.m. So yeah, it will be a lot of fun to me too. My name is Jakub, and you may already know me because I'm here for the third time. I work for Passion as iOS developer. I run my own blog, so if you want to just come and visit. And you can also find me on Twitter and on GitHub if you want to. And tonight I'm going to go nuts with just functions. So the agenda for the talk would be to, first of all, remove all the classes and objects from the code, then use free and pure functions everywhere, and introduce a lot of custom operators. And if you're like, what? Then yeah, this is the agenda for tonight's talk. Actually, I'm going to show you how to use just free, pure functions for your Swift code. And if you are wondering whether you should maybe leave this presentation now after the agenda, just like that, then please don't. First of all, it would be rude to me. And second of all, I promise that after the end of this talk, you might like the idea at the end. So in order to understand why I want to use free functions, let's first recap how object-oriented programming works. So usually we write our classes which describe objects, and we have two interfaces, the public one and the private one. When we interact from the world with an object, then we basically have some kind of a description for every method, which is the arguments on the input and also the output. But the hidden input is the state of the class, and it's also the hidden output because we can always mutate that, and we can't see that from the outside world. So imagine we are starting a new project. We have the beautiful stateless class like that. In this case, it's a sinus, but it doesn't really matter. It just takes in a value and returns a computed value. And a very nice property of that class is that it is very testable. So every time we give in the same input, it will give us the same output. What will usually happen when we develop the project, inevitably, like a product manager comes to us and asks that this sinus class actually needs more user touch to it. So what happens is that we introduce a dependency, the external one, which is the text field that allows user to type in something. Then we take a value from the text field, compute it, cast it to double, and then we use it to compute a value of the sinus function. So what happens is now when we pass a value to that, then when we try to debug any problem with our code, we can't really tell what happened because we had that internal state that's really hard to track. We would have to go through all of the application history. Of course, what we could do instead is just introduce another parameter to the function, and it would make it still very testable, very simple, and for the same pair of input arguments, we will get the same output. But unfortunately, with object-oriented programming, what's going to happen is that it actually encourages you to have the internal state hard-coded like in this example. So that's the first problem with object-oriented programming. Another one is with bound methods. So imagine that we have two methods like that, the square one and the sinus one, and now we want to compose them and chain them together possibly. In order to introduce another method that's chained, we need to have a code in order to reuse it. That's basically another bound function. And then in this function, we just compute first the square, then the sinus. And for every permutation of the functions that we want to invoke, we would have to give it another implementation, which doesn't really make us reuse the code in this pattern, even though if we could just not copy-paste that much. And here is where the functional programming comes into picture. So first of all, functional programming, by design, is about writing functions that are pure, which means they have no hidden dependencies, and all All it computes on are the input values for that functions, and of course all that the function produces is described as the output. And the very nice property of a function like that is that whenever we give it the same input value, we always get the same output value. Okay, so what happens is that by just structuring the code using pure functions, we have no hidden state. And we are using immutable data structures, which means that our code is very testable, because we can just pass in parameters, and also very thread safe, because there is no reliance on hidden state. So even if the function is paused, like in the middle of that, then if the program comes back and wants to execute it again, there is no risk of any mutation that should affect our computation. Okay, so that kind of fixes the first problem of the object-oriented programming that I have diagnosed for you. It's by design. The other problem was with the method composition. And in functional programming, it's very simple. So we can have like an operator that just composes two functions. So this operator, given two functions that have matching output and input type, can just give us a function that goes from the first function input to the second function output. And it's just a universal math law that we can describe using that operator. How could we use that? Imagine we have a free square function, similar to the one that was presented as a class. Then if we want to compose the function, we can just pipe them through together. And in this case, we are piping the output to the string initializer, which means it allows us to convert the value to the string. And for every permutation of those two free methods, we can basically compose them freely, and we have another function. That's, of course, pure and very easy to test. Of course, if we have a lot of free functions like that, we will inevitably land in bracket hell. Because given an input value, if we want to transform the usual way, what happens is that we have to chain a lot of methods together. So in this case, if I wouldn't split this code into separate lines, it would be pretty hard to reason about. It's of course very nice, testable, but we don't really want to write a code this way because it doesn't serve for humans too well. So what we could do instead is have another operator. This time it's forward appliance, and it's even more straightforward than the one I've presented before. It takes in a value and takes in a function that can process that value to different argument type. What it does, underneath, it just applies a function to that value. And why would I need that simple operator? It's just for readability purposes. So right now, we can have a double value, and we can process it with every line of code. So we can apply a sinus and square function composed to that value. We can square it. We can have an anonymous function that processes that. And we can also finally pipe it to the string initializer. And we are processing our results in this very simple manner. And it's very readable because every line is like a single transformation. So we might say that we finally have some order in our functional programming world. And the order is pretty important. It's not about the first order this time, but about higher order functions, which are very tightly coupled with functional programming. So the higher order function, by design, is a function that can take in one or more function as a parameter, or it returns a function as a result. There are those three higher order functions that are probably very familiar you're very familiar with, which is the filter. So given an array of integers, we can pick only the ones that are greater than 1. Then we can apply a transformation to every single value. And finally, we can compose the value into a single integer by summing up all of the results. There is also the other very, I would say, useful higher order function, which is called carry. And it's not a chicken curry and not even a Steph Curry from Golden State Warriors. It's just a free function that takes in a function as an input and returns that function in a way that it can be partially applied to the first argument, then to the second argument, and it gives you the output result. And we can implement a carrying function for an arbitrary number of arguments by using the approach presented. Why would you ever need to use that? Imagine we have a function that will tell you whether the second argument is divisible by the first one. So the order might not be too intuitive for us, but we'll get to that later. And using this function, we can say that 8 is not divisible by 3, and 81 is, of course, divisible by 9. So what it gives us, imagine that we now want to find only even values. So we effectively want the same function with the first argument hard-coded to 2. So now using carrying, we can carry our original function and partially apply it to the argument of 2, which will give us another function that takes in one argument. And it's just a number that we want to say whether it's even or not. And this way we can reuse the function. We didn't have to implement another one. We've just used partial appliance. What's very nice about Swift is that all of the bounds method can be by default carried, and it's not a common knowledge. So imagine you have an image like that, and we have the JPEG data function. That is a class method. It takes a single float argument as an input and returns the data of the compressed image. So now, if we take out this instance of an object and we use the type name instead, we will get a function that goes first from an object, from an instance of that object, then to all of the arguments of the original function, and finally it returns the same data type as the original method. So using that knowledge, we can take that carried method, apply it to the image, and apply it to the compression quality, and it works exactly the same as the method that is bound to a type. But we have removed like a dot syntax effectively. What's not so convenient about this approach is that usually in functional programming, we would like to have the data that is processed last, and the first we would like to apply it to a configuration, which in our case is a compression quality. So we would effectively like to reverse the order of the two, so that we can take a value and then apply the function with the hard-coded compression quality. And we can always do that. We can have a flip method that takes any carried function like that and returns a carried version of that function with flipped order of the first two arguments. So how could we use it? How could we apply that to our JPEG data method? So we have the original method in there that goes from image to float to the data. And then we can have a flipped method. And it goes from the CG float, which is compression quality, to image to data. Now we can create a brand new method that has the compression quality hard-coded. And in this case, we'll call it JPEG data. It goes from image to data. And then we can have our original image, and we can pipe it to the JPEG data function. And we kind of enforced the function to allow us the composition that we have seen when I introduced the forward appliance operator. OK, so we know how to deal with bounds method now. But how to deal with views using the functional approach? So styling views is something that might be probably the biggest benefit of the functional approach for all of you guys who don't really want to have like a lot of custom operators everywhere and a lot of free functions everywhere. You just want to use it to something very simple and practical. So how can we apply that? First, let's take a look at how we usually deal with that. So usually when we are having like a default style for a component, like for a text field or for a button, what we do is we create a subclass of that text field, and then we apply the styling functions in the initializer. And the really poor thing about that approach is that whether we want to have like two different types of views, like a button and a text field, we are effectively copy-pasting the code for the styling. So we have two the same places, which are both bordered with a border color and the same width of the border, and we have that code copy-pasted into two different base classes. What's worse is that if we would like to have a button that is rounded, we cannot have a default rounded button because we can't inherit from two base classes. We have to take the biggest of the two source classes and, of course, copy-paste the code that is used for configuration. That's not really convenient. And, of course, we can do it better by using, guess what, functions. So we can have a free function, let's call it bordered, and this function will take a color as a parameter. What it does, it takes any view and returns nothing. It just applies a style on that view. So we return that, this is the body of our function. Those are two lines that we have copy-pasted previously. And we have like two another functions. One of them is called rounded. It just applies corner radius. And the another one, for the label, converts the label to display more than one line of code. And how can we apply those styles? We can take our forward appliance operator. Previously, it worked on any given value. Now we want a one that operates on classes specifically. So we constrain the A to work on any object only. And given the fact that we have a value that is a class value, we can have a function with that shape, which takes in that value and returns nothing. And what this forward appliance would do is just apply that function and return the value that was mutated in place. And using that forward appliance type, we can create our label, apply the multi-line style, and apply the bordered style. And what's very convenient about this approach is when we want a button and we want to create it like that, we can reuse the same style every given time. We don't have to copy-paste it. It's just a function that resides, have single implementation, and we can reuse it to different view types. Of course, having a styling function like that, it wouldn't be very convenient because typically those styles, those base ones, are very, very short. So it's one line of code, two lines of code. What we would ideally like to do is to compose them into bigger styles. And we can do that. So let's have another operator. It's called same type composition this time. And what it does, it again operates on instances of classes. And it takes in two functions that have the same shape as the styling function. It takes in an instance of the class as an input, returns no output value. And having two functions like that, we can create another function with the same shape that basically applies the first and the second function, and it basically composes them. So how can we use that in practice? Let's imagine we want now to create a bigger style for a label. So we can have a function that goes from label to no return value, and we can just take our small styles, and we just compose them like that. So we can use anonymous functions, we can use our predefined styles, whatever we want. And of course, we can, for another view type, like a text field, we can just reuse the same styles, like rounded in this case, to build a bigger ones and store them, use them in a program just like a CSS code would do for the HTML pages. So it's very, very convenient and very nice way of styling your views without copy-pasting too much. Okay, so we know how to deal with bound methods, we know how to deal with views, but now functional programming is more about, or excels when we are transforming a lot of data. So let's try to morph something. It's morphing time now. So for the transforming data, let's first recap a pretty nice or a handy value of handy functionality of Swift, which is a keepf. So given a structure like that, we can have a type safe accessor that's generated by the compiler, and it's a keepf. It generally says that there is a way on the user structure to access the ID property of the integer type. And using that keepf, we can extract the value of the property like that, Or if it's a mutable key path for the variable like that, or rather writable key path, we can mutate that value in place using the key path. Of course, in this example, it's totally useless because we could just use a dot notation. It would be much more concise, but we will use the key paths for something else. We will use the key path to build a function that's an arbitrary getter. So it can take in a generic root object type, and it can take in a generic property of that object type. And if we have a key path that goes from the root object to that value type, we can have a function that takes in arbitrary root value and returns that property value. It might not make much sense right now, but how should we use it? So imagine we have a user. We can now take a user and pipe it to our functional getter, given the key path in there. So we are basically having the same behavior as extracting the ID directly. Of course, it still might not be too convenient currently, because this one is way shorter and way more clear. So how can we use this functional getter? Let's take a slightly more convoluted example, and let's operate on an array of users. And let's say we now want to find all the users that are adults in our system. So let's try to build that from functional pieces. First of all, we need a function that can tell us whether the user is adult. But we will implement that in a very particular way. So we will only take current date as a configuration parameter, and we will return a function that, given a date, can return us a Boolean value, which indicates whether a user or customer or whoever with that birth date is an adult. So what we are doing in here is basically comparing those two dates and checking whether the year component is greater or equal to 18. And this one, keep in mind, it's very generic. It does not know nothing about the user, even though we will operate on users later. It just knows about the dates. And also, the date in the original user structure was optional. And in this one, it's not. So keep that in mind, that this function can be copy-pasted to your code base. It would still work, even though I have a user defined there. Then we can have a map function that works on the optionals. And it's the same map function that's defined on the original optional in Swift. So given any transformation from A to B, it gives us the way to transform optional A into optional B. And why do I have to define it this way? We could try to carry the bound method on the optional type, but unfortunately it's generic. So in order to carry it, we would have to specialize the type of that optional, which is not very convenient. We would get a carried version per every optional type in our system. So it's better to introduce a free function once like that. That's generic. Also, we can have a function that, given any optional value, will return us non-optional value, but by just replacing the nil with a default one. Having those blocks defined, we can try to find our adults in the system. So we have 3 users. The first one is not adult, the second one is adult, and for the third one, we don't know the birth date, so it's not adult in our case. We take the method isAdult, hard-coding the current date. In this case, it's hard-coded to give consistent results. And now we have a function that goes from the birth date to whatever the user with that birth date is adult or not. And now let's take an array of the users, and we can filter that by composing a method for the user to say whether it's adult or not. So we extract the birth date, we map the optional value with our isNowAdult function, and in case it was nil, we replace that with false. So what it does, it's just compose those 3 very generic functions together. They know nothing about the user, they know nothing about the dates being optional or not, but yet we are able to filter out those users who are adults. So we have composed a function like that. Of course, we could try to write it like the old way. So what would happen is that we would have a filter function that on the user would take the birth date, which is optional, and map over that optional value with our isNowAdult function. What's really I would say, worrying in that example is that we have, in two cases, we have this $0 notation. And in one of them, in this one, it denotes the users, because a single user, because it's an argument of the filter function on the array. And in this case, it's a date, the birth date, that it's optional. Of course, we could try to just get rid of that closure and try to pipe in the isNowAdult function directly, but it's just to illustrate the problem that we have, that given more transformations, we would have more those unnamed arguments that mean different things in different contexts. Okay, so if you compare the two, it might not be obvious why should we use the functional approach. So let's go deeper, and let's now try to find not adults. So yeah, here is our usual approach. So the function we had previously, the anonymous function we have defined, we have to wrap it into brackets and negate it. But what about the composition? How would it work? We just go with the same transformation, and in the last step, we pipe everything into the not operator, and it magically works. It's the same code there. It looks the same for, this part looks exactly the same as for adult, of course, like you would expect, and it's way more clear than what happened in here. But if you are still not convinced, let's go one step deeper. So let's try to find reactive not adults. Imagine that we have a stream of array of users, and now we want to have a stream of array of adults. So what would happen is that we would have to map over the event. Then we would have an array that we would then need to filter with our isNotAdult function. And I don't know about you, but if I would get a code like that during a code review, I would be like, sorry, that's not gonna work for us. We can, of course, get rid of that using the functional approach. So let's define our filter method. It's similar to what we have done with optionals. So instead of trying to carry the filter method on a sequence that's generic, we introduce one generic function that, given a function which tells us whether we should keep that value or remove it, it gives us a way to transform the array of a given type into different array with not matching objects removed. So now we take in our observable stream of array of events, and what happens is that we are using the map method, we are using our free filter function, and then we pipe in the whole method that we have composed previously into that, and it works exactly the same, but it's way, way more readable. And of course, it's not the end, because we can refactor that further. So we can, for example, have the reversed version of our forward appliance operator. Let's call it backwards appliance. And the only difference is that the function is now on the left side and the value is on the right side. But apart from that, it works exactly the same. This operator is just for humans, for readability purposes. And now we can extract our function, isNotAdult. It goes from user to Boolean, and once again it extracts the birth date, maps the optional date into isNowAdult function. In case the birth date was nil, it returns false, and then negates the whole chain. And finally, on the stream of array of users, we just map the stream with the filter method, and we pipe in our new isNotAdult function inside. So let's recap. We had an observable stream of array of users. We had that code in the first place that we wanted to refactor, and we have finished up with that kind of code, which is way clearer, way more readable, and once again, it's composed of the functions that have absolutely no idea what happens in your system. So the get function does not know about the user. The map function, it doesn't know anything about the user. And the same goes for the not operator and the sum function. You could basically copy-paste those building blocks into your code base, and you still would be able to use it effectively, despite not having users in the system at all. So yeah, we had that. We have refactored to this version, so the refactoring was pretty good. But of course, it was all about transforming the values or trying to filter the values out. But unfortunately, sometimes we have to also break something, which basically in our world means that we have to mutate values. So previously we had our functional getter, so we can of course define a functional setter. In this case it's a function that takes in writable key path, so this is the key path that we are able to modify. Oh, sorry. Okay, it works again. So the function takes in a writable key path and it returns us a very peculiar function. This function, given the way to transform values, will give us a way to transform root objects together. So it might look very complicated from what's described in here, but let's try to look at the body only. So what it does is takes a value, copies it, and on the property, that's the node with the key path, applies a mutation that's defined and returns a mutated copy. For example, if we have a user with age and array of pets, given the user that's 25 and have one pet, we can just take that function, apply our functional setter with age on it, mutate, transforming the age by incrementing it by 10, and also we can do the same with the array of pets, just adding 2 pets to the array. And as a result, after those 2 transformations, as expected, we have a user that's aged 35 and has 3 pets. Comparing this approach to the imperative one, when we first copy the user and then apply transformations one by one, it looks very similar in amount of code we have to write. So the only benefit we had now is to basically we have hidden away the copying operation, which is not, I would say, very justified. So let's again go deeper and let's try to partition users. Of course, we are partitioning users, not hard drives or anything like that. So we are going to take our users and try to split them into 2 different sets. One of them passing our test, another not passing the test. And to do that partitioning, we will introduce another strange functional type, which is called either. And it's very, very simple. It's just an enum that has 2 cases. And it's either the left value, which is of type A, or either the right value, which is of type B. Why would you need that type in your code base? Imagine you have a user profile screen, and you have a picture of the user in there. What you usually would like to do is to fetch the URL of that picture from the API, but also allow the user to modify that picture. So when user taps on that, you go to the gallery, you have the image back, and then before it's uploaded to the server, we don't have any URL. We only have the image in there. So the approach to model that would be to introduce a structure that has optional URL and optional image. So in case the user has the image defined by the server, we are using URL. In case we are dealing with the one that's picked from the gallery, we have an image like that. The problem with that structure is that we are handling 4 states effectively. The one state being those 2 are optionals, which are both nil, and we don't really want to do that because we will always have a placeholder in there. But what's worse, we also have the case when we have both URL and image, and we don't really know what to do with that. And that's our error, but Swift compiler won't check it for us. So instead, we can use our either type to say that the avatar is either URL or image. And now the compiler will only allow us to have 2 states, both of them being valid. The either type might be mutated, so we can have a function that transforms the left side of that either. So given a function, it can just process that either, changing the left side type. We can have the same function for the right side of that either. And using that either type, we can have a very particular partition method, which takes in the partitioning, saying whether the given object is in the first or in the second partition, And it gives us a way to transform an array of objects into array of either A or A. It might look strange, but this partitioning, this particular version, is pretty nice. It has a pretty nice behavior because it actually keeps the order of the original array. So what will happen is that all of the items passing our test will end up as being the left side of the either and the others on the right side of the either. Given this strange type, which is either A or A, we might want to extract the value later, so we can have a function defined like that. So no matter what's defined in there, we can just extract the value. And now let's come back to our nested mutations example. Once again, imagine that we have users. This time, we are running a social community, and our users have ranking attached. So the bigger their ranking is, the more respected they are in our community. And we also have paid subscriptions to the system. And the subscription is optional, so you don't really need to pay. The subscription, of course, has the end date because it's not forever. So in case this date expires, our subscription is not valid too. And now what happens? Maybe the Christmas came, so we want to reward our users. So first of all, we really love our subscribers. So for all the subscribers, we want to bump their rank a little bit, and also we want to give them 1 month free subscription. But we are very greedy, so we don't really like our non-subscribers, and we want to punish them really, so we will just decrease their rank. So given 2 objectives like that, we can now proceed to build a functional way to approach that. So first of all, we need to have a way to test whether the user has active subscription or not. And we can, of course, compose that. So on the user, we extract the subscription end date. It's an optional date. So we go deep into the optional and test whether that date is greater than current date. In this example, it's hard-coded, but usually we would just use the current date in there. And in case that date was never there, we just map it to false, so the user has no active subscription. OK, we know how to test whether a user is active subscriber. Now we want to be able to prolong the subscription. So let's implement a method that, given amount of months, can give us a way to transform the date into the other date, which is just by adding those months in there. Please don't force unwrap in production code. OK, and once again, in that function, we don't know nothing about our users, about optionality of the dates. It's just a function that can transform any date into any other date. You could just have this function in your code base and use it whenever you like. And now, using that function, we can compose a method which transforms a user into a user. What it does, it takes a subscription. It's an optional, so we dig into that optional with map method. Then we take the subscription end date, and we increment that date by 1 month. And this way, we can have a function that for any user can give us a copy with incremented subscription end date. In this case, once again, I have reversed the function composition operator, and it's just for readability purposes for humans. Because if you would the standard one, we would have to go from property to map to subscription, which is not what we usually see. We want to transform a user, so we want to go this way, from subscription to the end date. That's why the operator is reversed, for the types to match. So we know how to prolong the subscription, so let's finally update the rank. Let's compose another function that, given a rank change, can give us a way to transform one user into another user. So it's just our functional setter on the rank property. And in here, we basically are covered if the value that we want to increment the rank with is negative, we will never go under 0. So this is why the max is there for. And we have a function which can, once again, transform one user into another user. And finally, having the array of all our users in the system, we can perform our objectives. So we take the array, we partition them using our hasActiveSubscription method, We dig into that array and to the left side of that array, and for every user passing the test, we prolong the subscription and update rank by bumping it by 10. The same way for non-subscribers, we just decrease their rank by 25. And finally, because this result is partitioned, we extract the value for the users. So some composed methods, 5 lines of code, and we are able to achieve the result like that. Does it work? Yes, it does. So given the array of 4 users, and the first and the last one having the active subscription for our current date, if we apply that transformations to that array, we'll see that the first user and the last user have their ranks bumped, also the subscription date prolonged, and the other 2 users has their ranks decreased and subscription was left intact. So let's recap once more complete snippet. We have the array of users. We have composed ourselves a function to check whether the user has active subscription or not. We have composed ourselves a function that can prolong a subscription for the user. We have composed a method to update the rank for the user. And finally, we take our users, partition them, and just apply the transformations that we want. Compare it to the old way, we would do it probably without extracting the code. We just map over the users. For every user, we test whether that user has an active subscription. Then we copy the user. We update the rank in 2 different branches. Then we have to copy the subscription. That's optional, incrementing the end date. And then finally, we return that copy. So this is the old code in a single map. And this is our new way with a couple of methods composed. Way more clearer to use and way more reasonable for the human. And also, one more thing about that is that probably if you take anyone who doesn't know nothing, who does know nothing about Swift code, and you show him this kind of transformation, he will still be able to read what's going on. Okay, so finally, to conclude this presentation, I should give you some pros and cons of that approach, which is functional approach. But I think it's pretty obvious from watching that presentation. So the pros are that the code is very composable. We have very small functions that we can compose together, chain together, and we have a lot of new functions. We can test it in a very, very nice manner because they have no side effects, and we can test them very granular. So going from the bottom level, many tests, to the top level with a fewer tests. And it's very easy to read once implemented. The cons are obviously the custom operators, which all of the iOS guys seem to hate. And also the problem is that when you see that code the first time, or rather when you try to implement something this way, it has a learning curve, and it's similar to Eric Swift in that case, for example. You have to learn a lot to be able to write a code like that. You have to know a lot of functions and how to compose them together. So what would I recommend for you? Please do not try to jump on the bandwagon or just try to remove that, just forget about that presentation. Please try it yourself and see whether the pros outweighs the cons for you, and then try to gradually implement that into your own work. And having said that, I would like to thank you for the presentation. In case you need any further references, you can first of all go to point3.co. This is the site that have a lot of tutorials on functional programming in Swift, and everything that was covered in this presentation is probably there, with a lot of more from them. So you should definitely go and check this out. What's more, please learn Haskell. I know it might sound like a stupid idea, but given the different approach, you can then port everything what's best about that approach into your own work. And in case you really want to program something in a functional way, you have 2 libraries. The Prelude one, this is all of the custom operators I have mentioned, and the Overture, which is similar to Prelude, but without custom operators, just named functions. And finally, you can download the slides from that presentation on my blog. Thank you very much.
Are there any particular areas that you really recommend, apart from, of course, styling that you've shown, that you recommend if I want to try some of this functional stuff in Visual iOS app, like maybe the data persistence, networking layer?
Yeah, so one of the approaches that, or the problems that you could solve with that is, for example, if you have an offline app like we had back in the days, and you have a lot of models that are not really, I would say, processed, so they are pretty raw, like a very relational, and you have to do a lot of data transformations. That's one place when you definitely want to check this out. It helps with the memory management a lot, because with functions you don't have to really worry about that, while when you are using objects and you are processing that, especially in a reactive way, you have a lot of unknown and weak selves and etc. to connect that together. So transforming the data is very, 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 I would say, valid use case for that. That's the first one that comes to my mind, really. And yeah, the styling one is pretty good too. So every part, when you need to transform the data or operate on the data, whether it's an API or the database, it's a pretty nice way to start or try it.
What about the testability of this approach? Because the pros of the object-oriented approach is that you can usually extract some part of the logic and provide different implementation of it in the production code and the test. So you cannot really inject a different function under the same name, can you?
Yeah, so first of all, like all the real-world dependencies, you would inject the same way you did, like I did with the dates and etc. So that's testable. And for the other part of your question, there is some very big, I would say, misconception about unit testing, is that you need to isolate absolutely everything. And if you follow, for example, Uncle Bob, and you would go through all the articles and read it very carefully, you would know that it's not like you have to isolate everything. You had to isolate what you have to isolate. What do I mean? I mean that in case of functional approach, you have the smallest functions that you can test throughoutly. And if you have a bigger composition, then what you should do in there is not try to stop one of the functions. You should just try to test all the chains, but just with less amount of corner cases than you apply. So you build top up, and all the functional core that you have, you don't really have to stop, because it's testable anyway. It will always give you the predictable results. So you don't really have to replace that function with another function. You can just go through the whole chain and test it together. And this way, even if you refactor the app, it's still, you have the valid tests in there. And in case if you try to isolate too much, then if you try to extract another interface, nothing compiles suddenly. And your test just verifies whether you have called another method passing arguments. So it's, I would say, way more testable than our objective-oriented programming approach.
I have two questions for you. First one is, have you tried to introduce that concept in the company? And I'm wondering what was the reaction of your colleagues.
You can ask them, they are sitting there.
Well, I know from this guy, but
yeah.
I don't know about the rest. Because I'm having some hard times to convince my friends at work to try to write functional programming as well. And I'm wondering if you, because I assume you went through all the episodes on point tree as well. I'm wondering what's your take on ambient dependency injection, and if so, could you elaborate some more about it?
Yeah, so I'll start with dependency injection because it's way easier to answer first. So in case you want to use it in a production code, first of all, you should probably look at the talk from NS Spain. That's from one of the guys of Point3. It's about modeling the world. And what they do in there is they're having this giant, I would say, structure or a singleton that they operate on. Don't be scared. Which has all of the world dependencies that are isolated, and then you can control them in the test. So this is probably the way you would try to approach injecting dependencies. Of course, the different approach we have seen in there. So we have a function that returns a function, and all the configuration is the argument to the original function. So this is how I would go about it to answer your second question. And for the first question, I don't really know. I think that they wouldn't be really keen on that they've never been in the past. But I'm using that approach in my, I would say, private project, which is already on the App Store to a pretty good extent, and I really love it. And I remember when I started working for the company, I came there and we've worked with apps that had no tests in it, or at least one app, and then we gradually built something different together. Now we have a lot of unit tests, so probably if you speak to me like in 2 years, we'll be using functional programming a lot, but you need to give me time.